Hello everyone, this is Sri Raksha, student of SVCE from the Department of Computer Science and Engineering. Well, in this video I am going to discuss about the subject Database Management System. The topic I am going to discuss is about the ER diagram. Introduction to ER diagram. ER means Entity Relationship Diagrams are the fundamental tool in database design, which is used to visually represent the relationship between the different entities or objects within a database. These diagrams provide a clear way to model the structure of the database, making it easier to understand, communicate, and manage the data. By defining the entities, their attributes, and the relationship between them, ER diagram helps ensuring the integrity and effectiveness of the database system. Next one is entity types and attributes. Entity types represent a distinct object within a database such as customer, producer, or employee. Each entity type has a unique set of attributes that describes their characters. When it comes to the attributes, these are the individual piece of information that defines an entity type. They can be simple such as name or age or complex such as address or list of phone numbers. Next one is key attribute. Key attribute are used to identify uniquely and each instance of the entity type, ensuring that each record in the database is distinct. They are also known as primary keys. Next one is relationships and cardinality. When it comes to the relationship, it defines the connection between entity types. There are one-to-one, one-to-many, many-to-one relationships that are essential for understanding how the data is linked within the database. Next one is cardinality. It describes the numerical relationship between two types of entities. It specifies minimum and maximum number of instances of one entity type that can be associated with another entity type. Relationship strength. It is important to know whether the relationship is either the strong entity or a weak entity. Next one is about the constraints. There are four constraints, that is key constraints, unique constraints, null constraints, and foreign key constraints. Let's see about the key constraints. Key constraints ensure that each entity instance is unique and can be identified. They can be primary key, which uniquely identifies each record, or candidate key, which alternative unique identifier. Next one is unique constraints. Unique constraints ensures that the value of specific attribute or a combination of attributes is unique across all instances of an entity type. It helps maintaining the data integrity and preserve duplicates. Next one is about the null constraints. Null constraints determine whether an attribute can be left empty or must contain a value. They ensure that required information is provided for each entity instance. Next one is about the foreign key constraint. Foreign key constraint establish relationship between the entities that requires the value of an attribute in one entity must match the value of a primary key in another entity. It ensures the referential integrity. These are the symbols of ER diagram. Rectangle box is used to represent entity. When there is a two rectangle box, it used to represent a weak entity. This rhombus shape is used to represent the relationship. Attributes are represented in a oval shape. With underline, it is represented as a key attribute. Multi-value attribute is represented by two oval. And then composite attributes is represented like this. Derived attributes is also a dotted line of ovals. Total participation is represented by two lines. Cardinality ratios. Let's see the types of cardinality ratios. That is many to many cardinality, many to one, one to many, and one to one. First one is many to many. By these cardinality constraints, an entity in set A can be associated with any numbers, that is 0 or more, of entity in set B. An entity in set B can be associated with any number of entities in set A. This is the symbol we use for many to many cardinality ratio, that is m is to n. Let's see an example. One student can enroll in any number of courses. One course can also be enrolled by any number of students. This is an example for many to many relationship. Next one is many to one. An entity in a set A can be associated with at most one entity in set B, or an entity in set B can be associated with any numbers of entity in set A. Let's see an example. One student can enroll in at most one course, whereas one course can be enrolled by any number of the students. This is an example for one to one, many to one relationship. Next one is one to many relationship. An entity in set A can be associated with any number of entities in set B, whereas an entity in set B can be associated with at most one entity in set A, and it is represented as 1 is to n. For example, one student can enroll in any number of courses, but one course can be enrolled by at most one student. This is an example for one to many relationship. Next one is one to one cardinality. An entity in set A can be associated with at most one entity in set B. In the similar way, an entity in set B can be associated with at most one entity in set A, and it is represented as 1 is to 1. For example, one student can enroll in at most one course. In the same way, one course can be enrolled by at most one student. An example for one-to-one relationship. Next one is translating ER diagram to relational schema. It requires entity type, relationships, and cardinality ratios. Conclusion. It is important to know about the ER diagram as it is a crucial tool for understanding and designing database management system. Key concepts. It covers the important topics such as entity types, attributes, relationship, cardinality, constraints, and ER diagram. Thank you.